Welcome back to The Explainer. Today, we're jumping right into Body Decoded, the anatomy of the wrist. But, before we really peel back the layers, I want you to do something quick for me. Just hold up your hand, take a good look at your wrist, and flex it around in a circle. Go ahead, wiggle those fingers, bend your hand back and forth. It feels entirely effortless, doesn't it? Well, beneath the surface of your skin lies this truly incredible piece of anatomical engineering. So today, we're going on a visual journey to decode the healthy human wrist. Think about the very first thing you did when you sat down with us today. Okay, let's dive into this. What exactly are the complex mechanics that allowed you to seamlessly reach out, grasp a mouse, or tap a screen, and just click play on this explainer? We take our healthy hands completely for granted, we really do. But the truth is, your wrist routinely absorbs force equivalent to several times your body weight during a simple fall. Yet, at the exact same time, it houses these delicate structures that allow for movements so incredibly refined, we're actually only just beginning to truly appreciate them through modern medical visualization. Our source material sums this up perfectly. Your wrist is a masterpiece of precision, and I really want us to adopt that mindset today. We aren't just looking at a simple hinge or, a standard joint. When we conceptually peel back the layers and look at the ultra-high detail of human anatomy, we find a system that boasts absolute medical textbook accuracy in its natural design. It's an intricate structure, and it operates with staggering complexity every single second of your waking life. To put this into perspective, think about writing a letter, typing an email, or catching a ball. These seem like basic everyday tasks, right? But these actions require literally thousands of coordinated microscopic movements. To pull this off, your wrist has to provide your hand with an unbelievable balance of ultimate flexibility and unwavering control. It has to be stable enough to catch a fast-moving object, but delicate enough to type at lightning speed or write with intricate penmanship. So, to truly understand how this works, we're taking a macro to micro approach. We'll start with the skeletal foundation, move to the connective rigging, and then finish up with the microscopic wiring. Conceptually, I want you to imagine the skin on the hand gradually becoming semi-transparent. We're going to peel back the exact anatomical layers, stepping into a cinematic, ultra-realistic view of our own anatomy, just to see precisely how these three elements interact to create smooth, controlled movement. Starting with that skeletal foundation, we're focusing on the outer architectural pillars of the hand. You've got the distal radius and the ulna coming down from your forearm and the metacarpals extending out into your hand. Now, these large bones form the critical skeletal frame. They're basically the sturdy pillars supporting the entire anatomical masterpiece. But here's the thing. The real magic of the wrist doesn't just happen in these large bones. It actually happens in the incredible gap right between them. And that brings us to an incredibly important number, 8. So the absolutely crucial point here is that nestled right in between those larger architectural pillars, between your forearm and your hand, are exactly 8 tiny carpal bones. The contrast here is just staggering. You have these minuscule, uniquely shaped bones packed tightly together, yet their biomechanical importance is massive. Seriously, think of them like a highly advanced biological game of Tetris combined with the shock absorbers of a sports car. They are the true mechanical core of the joint, acting as this dynamic bridge that translates power and motion. Those 8 tiny carpal bones don't just float in space, though. They're tightly bound together. Now, what's really interesting as we look at this connective rigging is how we can see dozens of ligaments, tendons, and realistic muscles at work. This complex rigging acts like a series of sophisticated pulleys and tension wires. They're completely designed to smoothly slide over the joint, keeping everything perfectly stable while still allowing for those dynamic, sweeping motions. Drilling down even further, we reach the microscopic wiring. Imagine gliding right between those 8 carpal bones. What you'd see is this vivid, brilliantly colored network. You've got bright yellow nerves branching delicately through the wrist, alongside red arteries and blue veins gracefully weaving around the bones. It's a completely frictionless, highly precise environment. And despite the really dense packing of all these vital nerves and blood vessels, they glide perfectly and naturally. They weave through this incredibly tight space without ever tangling, pinching, or snagging during movement. No way you'd expect that much traffic to flow so smoothly. So let's put this machinery into motion. When bending smoothly forward, you can see how those tendons we talked about tighten and relax completely naturally inside your arm. They pull on the skeletal foundation, guided by that rigging, while the microscopic wiring just effortlessly shifts out of the way. It is a seamless, buttery smooth process that happens in a fraction of a second every single time you curl your hand.
And this brilliantly illustrates what happens when we reverse that motion, extending naturally. When you pull your hand back to extend the joint, it requires those same 8 carpal bones to instantly shift their configuration. They glide together in perfect, frictionless coordination. It's essentially an intricate dance of anatomy where the radius, the ulna, the metacarpals, and the carpals all perfectly align in a split second. And that is what allows your hand to reach back with total stability and grace.
Finally, we have rotation. As you twist your wrist, rotating with perfect precision every single structural layer we've discussed, the foundation, the rigging, the wiring, works together in remarkable biomechanical coordination. The carpal bones slide, the tendons glide, and the nerves flex. All of this happening simultaneously is exactly what gives your fingers the ultimate accuracy needed to type a sentence or lightly toss a ball. It is, quite literally, precision in motion. As we conceptually pull back out, restoring the skin and viewing the complete, fully formed hand and wrist once again, it really comes down to this one thought: 8 tiny bones, endless precision. What we've just explored is an absolute marvel of natural design. From the macroscopic pillars of your forearm to the microscopic branching of your yellow nerves, your wrist provides your hand with incredible flexibility and control that we frankly rely on constantly. Which leaves us with this final thought for today's explainer. Look down at your wrist one more time. Flex it. Could human engineering ever truly replicate the frictionless perfection, the endless precision of these 8 tiny bones working in total harmony? It's a profound reminder of the architectural wonder you carry with you every single day. Thank you so much for joining me for this explainer. Keep exploring, keep questioning, and I'll see you next time.